Hi guys! Today Bambu Lab released one more 3D printer. The model is called A1 and can be ordered with or without the AMS Lite unit. In this video, we will show all the details about this new model and also the comparison between the A1 and the A1 Mini. You want to know more? Then stay tuned! Hi guys, welcome back. My name is Rui and this is the Rui Raptor YouTube channel. If you want to help us out, you can by giving this video a like and subscribe to the channel. You can also help by joining our Patreon page or by clicking on any of the affiliate links posted below in the video description. Today Bambu Lab released one more bed slinger 3D printer, the A1. This new model has some similarities with the previous A1 Mini. The print volume of the A1 is bigger when compared with the A1 Mini, with 256mm for every axis. It's the same printing volume of the X1 series and the P1 series. And it's available as standalone or with the auto material system. The main features of this new model are basically the same as the A1 Mini, which are the multicolor capability with the AMS Lite unit, which allows printing with up to 4 colors. It can run several calibrations automatically, such as bed level, Z offset, vibration compensation calibration, and flow sensing. The active flow rate compensation is one of the most interesting features. The machine has a sensor that can measure the amount of flow and make the necessary compensation. The manufacturer also promises fast speeds and print quality on this model, especially because this machine can print very fast like a Core XY printer, but with a bed slinger structure. The user interface is very user-friendly. As the A1 Mini, the A1 can also print with low noise levels. The hot end quick swap feature means you don't need any tools to replace the hot end, and this can be done in just a couple of minutes or even less. It's also equipped with a camera and light and can be monitored remotely with an app on a smartphone. It's also capable of detecting filament tangles while printing, which is very handy. The AMS Lite can also load and unload automatically, and it's equipped with the radio frequency ID reader to detect filament types from Bambu Lab spools. The structure is all metal and has linear rails for the X-axis, linear rods for the Z-axis, and linear guides for the Y-axis. It can print most of the materials on the market that don't require an enclosure, such as PLA, PETG, and TPU. But because it's an open printer, it's not recommended to print filaments such as ABS, ASA, PC, PA, and PET. The printer is also equipped with a filament runout sensor, filament odometry sensor, and power loss recovery. But what does this new model has different when compared with the previous model? That and much more will be covered in this video. But first, let's go through the unboxing. After removing the contents from the cardboard box, we see that like all previous models from Bambu Lab, everything comes nicely packed. Right at the top, we have the rollers for the AMS Lite unit, which are 4 in total. Then we have the user manual and the print surface, a small box with filament samples, a box with parts and tools, a mystery box, the AMS Lite mount, then we have another layer where we have the external filament spool holder, another part of the external spool holder, the purge wiper, the power cable, and the AMS Lite unit. And on the third layer, we have the top half of the printer. There is a warning on the X gantry saying not to grab this part from there, so we have to grab it from the sides. Finally, after removing the remaining foam, we have the bottom half of the printer, a small sample of filament, and a bag with PTFE tubes. Okay, and this is everything that came inside the package. The manual that comes with the printer has nice illustrations and clear instructions. Inside the box with parts, we have several tools, screws for the initial setup, spares, and lubricants. This is the purge wiper. It has a spring mechanism which is actuated by the print head and shoots the filament purges away. And this is the external filament spool holder. This is used as an alternative to the AMS Lite unit. The shaft needs to be installed at the side like this. As for the bag with PTFE tubes, since we have the combo with the AMS unit, it comes with 5 tubes, and some with different lengths. One of them will be used if we have the external spool holder installed, and the set of 4 will be used if we want to connect the AMS Lite unit. This is the AMS unit. At the top, we have the 4 feeders. The filament spools are placed at the sides. The spools are secured by rollers that we need to attach during the assembly. And these are the rollers. They have this spring system so they can be adjustable to different spool sizes from 40 to 68 millimeters of width and 53 to 58 millimeters of inner diameter. The print surface is this gold color metallic sheet with texture on both sides. The size is 256 by 256 millimeters. For the initial amount of units, a mystery box will be included. Bambu Lab did the same when released the A1 Mini. There are 2 new mystery boxes available, and we have received the jet engine kit, which includes plastic bearings and lots of screws. And this is the top half of the printer. After removing the protective cardboard pieces, this is what we get. Right off the bat, we can see that the print head is exactly the same as the previous model. It's equipped with the same components as the A1 Mini. It's a direct drive setup with an all-metal hot end. Under it, we can see the nozzle and the black sock covering the hot end. At the sides are the ducts where the cooling air for the layers comes from. The layer cooling fan can be seen from the back. As the previous models, this one has a lever at the side which is used to cut automatically the filament before unloading. One of the features of this printer is that the hot end can be replaced without the need of tools. To do that, we first remove the front cover. Inside there's a sticker with the instructions. Next, we remove the sock from the hot end. There's a metal latch that needs to be removed, and when it's removed, the hot end comes out. This hot end is stainless steel and, of course, all metal. Attached to the heatsink is a small magnet that holds the hot end while the latch is unlocked. The nozzle that comes with the stock hot end is 0.4 millimeters. On the manufacturer's website, it's possible to order the stock hot end or the hardened one. It's also possible to order with different nozzle sizes. The X-axis runs on linear rails and the Z-axis runs on linear rods. And at the right, we have a small camera and light. There's also a small piece to cover the camera if we don't want it to capture any images. The odd-shaped piece at the top is used to trigger the filament cutter. Every time the print head moves all the way to the right, it will trigger the lever and cut the filament inside the print head. At the bottom is the Z-axis stepper motor and the metal structure that will secure the top half to the base. At the end of the cable that comes from the print head, we see a couple of Molex connectors and a USB connector attached to this plastic piece. All these will connect to the base of the printer. And this is the base. At the top is the print bed. Being a bed slinger, the bed moves back and forth while printing. At the right side, we have the display which can turn 90 degrees. At the back, we have a couple of connectors. One is for the AMS Lite and the other is a spare. There's also the main power connector and the on and off switch. At the left side, there's only the air vent. And at the front is the memory card slot already with the memory card in it. At the bottom is the slot for the connectors we have just seen. The USB connector will be connected right here. Okay, now that we have seen all the parts, let's assemble the printer. First, we need to unlock the print bed. It comes locked to prevent it from moving and also to keep it safe from vibrations during transportation. There are 4 screws that we need to remove. Each one is marked with the red circle. To remove them, we can use one of the tools that comes with the printer. Okay, now the print bed can move freely. Next, we take the bottom half and attach carefully on the top half structure like this. From the back, we need to remove the cover to access the interior. Inside, we can see that the Y-axis moves on linear rails. We also see several green circles. These circles show the areas where we need to insert a screw and tighten each one. These screws will secure the base to the top half. On one of these sides, there's also a couple of holes with the indication of the axis for the belt tensioner. From the front side, there are 4 more green circles that we need to secure with screws. Once all that is done, we can now close the panel. Make sure the panel is correctly installed from the front side. Okay, now comes the tricky part. To access the bottom side of the base and to avoid messing with the squareness of the structure, we need to place the printer on the edge of the table or, like in our case, get something to safely place the printer. Make sure you get the printer perfectly laid like this and avoid getting the bed cable pinch in the process. Also, remember that the print bed moves freely, so be careful when turning the printer on its back. Now, take the cable that comes from the print head, place it on the slot, and carefully slide it up until the USB connector is connected. Connect the camera and the X stepper motor. And don't forget to tighten the small screw to secure the cable in place. There's one more connector that needs to be connected, and it's the Z stepper motor. First, pass the cable through the opening on the plastic piece and lock it, and then connect it. At the left side of the X gantry, we need to attach the purge wiper, and it needs to be secured with a screw from underneath. Now we can remove the plastic protective cover from the print bed. The bed is magnetic and has lots of strong magnets all over the bed, including at the edges. These are good to prevent warping of the print surface while printing. At the back, there's a rubber nozzle cleaning wiper. And now we can place the print surface on the bed. Placing the print surface on the bed can be a bit tricky for the first tries. It was always getting misaligned and we had to correct it. There are 5 PTFE tubes inside the bag and with different lengths. The shorter one is used when you don't have the AMS installed and connects to the fitting next to the external filament holder and to the print head. If you don't have the AMS unit or prefer to use the external spool holder, this is how you install it. Attach the spool holder at the top of the printer like this, and then lock it. Connect the PTFE tube on the fitting at the top, and then on the print head. You can connect the tube to any of the 4 fittings on the head. Next, we need to secure the cable on the collar. And this is how the printer looks like when assembled. The print volume is 256 by 256 by 256 millimeters. If you order the AMS unit, this is how you assemble it. First, take the base and place the AMS on the base. Next, take these screws and use them to secure the AMS unit to the base. You need 2 screws for each side. Next, cut the zip ties. And then, install the rollers. Each roller has a color, and this color must match the color on the AMS. There are a couple of green rollers and a couple of yellow rollers. The AMS Lite is not compatible with the X1 and P1 printer series, and the bigger AMS is not compatible with the A1. And this is how the AMS Lite looks like. There are several numbers at the top of the unit. The numbers from 1 to 4 indicate the slot number and the position. The filament is inserted from underneath and comes out from these fittings. The buttons release the gear so we can insert or remove the filaments. Now we need to install the tubes, and for that we will use the set of 4. The middle length tubes connect the fittings from slots 1 and 2 to the print head. And the longest tubes connect the fittings from slots 3 and 4 to the print head. On the print head, there is no specific order for the tubes. Just make sure they go from the print head to the AMS as straight as possible. Then we have this collar to secure all 4 tubes and the cable that goes to the print head together. You will have to make sure that all the tubes and cable can move correctly and don't get pulled when the X and Z axis move to the limits. This can be confirmed later with the print turned on. And finally, connect the AMS to the printer. There are a couple of connectors at the back of the printer. It can be connected to any of them. Although it has 2 connectors, it doesn't mean you can connect 2 AMS units. At this time, the second connector is just a spare and cannot be used for a second AMS unit. Okay, now just connect the power cord and turn on the printer. The display is a 3.5-inch color touch display. When turning the printer on for the first time, the display will show us an initial setup that we need to go through. First is to select the language, then select the region, connect the Wi-Fi. This one we can skip and do it later on. Agree to the policies, choose to join the user experience, and finally run the auto calibrations. These calibrations will take a few minutes to complete and will calibrate the motor's noise compensation and the vibration compensation. Once the calibrations are complete, the printer is ready to start its first print. The menus are very user-friendly. At the top, we have the information about the nozzle and heat bed temperatures, the camera icon, and the Wi-Fi connected icon. The button with the benchy allows us to access the memory card and choose one of the files to print. In filament, we can load and unload filament. We can also check the information of which type of filament we have on the AMS slots and on the external spool holder. If we use filaments from Bambu Lab, the RFID reader inside the AMS unit will identify automatically which type and color the filament is. If we use filaments from any other brand, we need to type in that information manually. In control, we can change the nozzle and heat bed temperatures, change the print speed, change the layer cooling fan speed, turn the light on and off, and turn the extruder. In the X, Y, and Z tab, we can move each axis and run the home sequence. In setting, we can check our Bambu Lab account, check the firmware version, check the Wi-Fi. In maintenance, we can run the calibration and enter the maintenance mode. We can also check the printer's ID. In print options, we can enable or disable the sounds, the step loss recovery feature, the AMS filament backup feature, and the filament tangle detection. There are a few languages we can choose from if we want to. We can also check some information about the memory card and format it as well. It's possible to change the screen off time, turn the LAN on mode on and off, access the terms of use, and do a factory reset. And last but not least, the assistant, where we can check messages and errors. In our case, we don't have any, so everything is okay. For the first test print, we decided to print one of the models that are already sliced on the memory card. This one is the Benchy that is printed very fast. Every time before each leveling, the printer moves the head to the back to clean the nozzle. This is important to prevent filament remains to interfere with the bed leveling. For this one, we used a spool of Bambu Lab PLA basic filament. Not counting with the initial setup, the Benchy was printed in only 14.5 minutes. Since this is a very fast print, we decided to measure the noise that the printer makes while running. The printer does not make too much noise while printing, except if it's printing at very high speeds and accelerations. The loudest component is actually the layer cooling fan when running at speeds higher than 80%. When reducing the fan speed below this point, the difference in noise level is pretty big. For values below 50%, it can't be heard at all. One thing you need to be aware of is the orientation of the cable that comes from the print head. If this cable is tilted back and falls behind the structure, the cable will be pulled and will prevent the axis from reaching their limits. The placement of the AMS unit at the back of the printer, in this example, might cause this to happen. But if you place the AMS unit at the side of the printer, the probability of this happening will be reduced. So guys, keep an eye on your cables and adjust your setup to prevent this from happening. We also noticed something that the manufacturer might need to improve. When we check the stability of the printer on a flat surface, we see that it's pretty stable. But when we load a filament spool on the external spool holder, and when the heat bed is fully at the back, we notice that it's not that stable. Please note that this only happens when the heat bed is fully at the back and only when having a filament spool on the external spool holder. This is because the rubber pads at the edges of the printer are too soft. The printer has additional rubber pads under the vertical structure, and these are more rigid. It might be a good idea to have rubber pads a little bit more rigid at the back to avoid this. We also tested printing a model with PLA silk filament. Next, we started printing the parts for our mystery box model, the jet engine. In total, to complete this model, we had to print 52 pieces. The adhesion on the print surface is very good. We didn't use anything to promote the adhesion. One thing we can't ignore is how well the first layer turns out every time. The filament pressure sensing, the bed leveling, and the Z-offset auto-calibrations sure have an important contribution on how good the prints will become. Then, we printed a couple of multicolor models and with the AMS Lite unit. The first one was this painting. It uses 4 different colors and it's printed with a 0.08mm layer height. And then we printed a small figure, again with 4 different colors. Filament purges are thrown away every time the printer loads a new filament or calibrates the flow. This is necessary to guarantee a correct extrusion and free from contamination from previous loaded filaments. However, the printer does not include any bin to collect those filament remains or any STL file to print one. Having something to collect the purchase is a must, otherwise we end up with filament remains scattered all over the place. However, there are several designs on Maker World that will work very well. If you enable the flow dynamics calibration on the slicer, the printer will run a flow calibration before the print starts. With the external spool holder installed, once again, we printed a vase with TPU filament. For flexible filaments, Bambu Lab does not recommend using the AMS unit. Okay, let's check how the prints turned out. First, the benchy. As far as we can see, there is no ghosting and the walls are smooth. Normally, these type of printers produce some amount of ghosting when printing at very high speeds and accelerations, but we didn't see that here on this benchy. There is, however, a transition on the surface of the benchy caused by different printing speeds. We also see no issues with the cabin arches. Aside from the transition on the surface, the benchy actually looks perfect, which is amazing. Not only because it was printed in just 14.5 minutes, but also because it was printed on a Cartesian type printer with very high speeds and accelerations. Regarding the model printed with PLA silk filament, this is how it turned out. We used the generic silk profile without any modification, and it turned out okay. After printing all the 52 parts of the jet engine, here are a few of them. The white ones were printed with Bambu Lab PLA filament. All of them look great, and the areas where it had supports turned out acceptable. The supports themselves were easy to remove. The parts in blue were printed with KXL PLA filament and turned out very nice as well. Some parts were printed with gray filament also from KXL. And finally, the black parts were printed with black filament from Bambu Lab. All of them turned out nicely. With all the 52 parts, the 4 bearings and screws from the kit, we assembled the engine, and this is how it turned out. As for the multicolor models and for the landscape drawing, it turned out amazing. The 4 colors created this cool scene. The first layer on the back side, and as we mentioned already, is perfectly flat. The small multicolor figure also turned out okay. One note regarding this model is that the green sphere over the hat was printed without any supports. The model printed with TPU also turned out okay. We used KXL TPU filament instead of Bambu Lab TPU, and we feel that we can improve the results a bit more by tweaking the settings a little bit for this filament. When comparing the A1 with the smaller A1 Mini, the differences are obviously the print volume, which on the A1 Mini is 180 mm on every axis, and on the A1 is 256 mm on every axis. The structure of the A1 is also different and more stable. The display is a bit bigger on the A1 as well. The display on this one is a 3.5-inch color touch display. And finally, the price. The A1 3D printer alone is sold at $399, and the combo with the AMS Lite unit is sold at $559. As for the pros and cons, and on the positive side we have the assembly. It's very easy to assemble and it will be ready to print in minutes. The print volume, which is 256 mm on every axis. The printer provides good results right out of the box, and therefore is a great option for a beginner. It's compatible with the AMS Lite unit, and with it can print up to 4 different colors. The printer's components and materials have very good quality. It's equipped with linear rails for the x-axis, linear rods for the z-axis, and linear guides for the y-axis. It has a color touch display with very user-friendly menus. It's equipped with light and also with a camera which allows us to monitor the prints live and also capture time-lapse movies. The print surface is magnetic and with texture. It also has a very good adhesion. For PLA filament, we didn't use anything to help with the adhesion. The hot end is all metal and can be replaced very fast and easily. The printer is able to make several calibrations automatically. It's equipped with a sensor that senses the filament flow while printing, and also a vibration sensor for the vibration compensation feature. It's also equipped with a leveling sensor and filament runout sensor. The printer is also able to detect filament tangles, which is very handy. Can print with high speeds and maintain a good print quality. The slicer provided by Bambu Lab is an awesome slicer, and also includes profiles which will work as is in most cases. Bambu Lab also provides an app for the smartphone to monitor and control the printer remotely. It has lots and lots of information on their wiki page, with maintenance instructions, troubleshoot tips, etc. The manufacturer keeps improving the machine with firmware and slicer software updates. As for the negative points, we have: since it's not included a bin to collect the filament purchase, we need to print one or something else to avoid getting filament remains all over the place. The placement of the print surface can be a little tricky at first. Maybe if the heatbed had a few pins to help guide the print surface, it might be easier. Although the printer can run with low noise levels, the layer cooling fan can be a bit noisy if running at speeds higher than 80%. We can only connect one AMS Lite unit and therefore can only print up to 4 colors. Although there are 2 connectors here at the side, at the moment we release this video, only one AMS unit is supported. So, for the guys that don't need to print with more demanding filaments, but need a medium-sized bed and want to print at higher speeds, the A1 is probably the best choice. So, what do you guys think? Feel free to leave your comments below. And that's it, you guys. Thanks for watching. We will see you guys next time. Bye!